Hi everyone, welcome back. In this video, we'll see the necessary conditions or the characteristics of deadlock. Guys, you know the deadlock is going to happen because of resources only, right? Yes. So here, necessary conditions is defining that if a deadlock wants to appear, deadlock has to appear in the system, it can have one of the following conditions, guys. Like one will be mutual exclusion, another one will be hold and wait, and no preemption, and the last one is circular wait. Because of these, one of these four existed, there might be a chance of occurring deadlock. What is the general meaning of all this? We'll explain. Guys, in general, mutual exclusion means only one process is allowed to use the critical section out of all the competitive process. So for example, in the same place, if I am going to have a resource Ri that can be used by only one process at a time, definitely there won't be any kind of deadlock. But if there is a shared resource, that has been used by many processes at the same time, there is having a chance of deadlock, right? Which means that processes which not following the mutual exclusion might lead to deadlock. But if a process will follow the mutual exclusion concept, definitely there won't be any kind of deadlock. Okay, next one, hold and wait. If I say that process PI is there which is holding a resource Ri and waiting for another resource Rj, then if you occur this kind of situation, there might be a deadlock. But if I say that deadlock exists, definitely there exists hold and wait, and vice versa is not true, guys, which is always not deadlock, but there might be a chance of having the deadlock. So you have to avoid always the hold and wait concept. Next one is no preemption. Guys, when some process is using the resource, so PI is using the resource, you should not allow to pull the resource from the process PI, guys, which I can say that as preemption is not allowed with respect to the resources. If preemption is allowed, what will happen? Like for example, if there is a resource which is used by process PI, and in the middle of the execution some other process PJ came and you stopped the process for this one and given chance to PJ, then process PI is waiting for the Ri, but it has allocated to PJ, so that might lead to a kind of deadlock. So what will be the solution for this one? So generally process has to release the resources voluntarily, right? Voluntarily, how it will do? It can do by its own interest or after the completion of work it can voluntarily release, right? So this is what you can call, so we can call it as resource, right? So means no preemption might not lead to deadlock, but if I say that there is a deadlock, there might be a chance of having preemption of resources is there. That is what this principle is saying. And the another one is circular wait. So for example, process P1, P2, P3, process P1 is holding the R1, process P2 is holding the R2, process P3 is holding the R3, and process P1 is requesting for R2, process P2 is requesting for R3, process P3 is requesting for R1. It's a kind of circular, right? Means the processor are circularly waiting on each other for the resources. Then there might be a loop. That loop will lead to a deadlock, guys. Okay, fine. So in general, if I say everywhere wherever you observe circular wait, that not led to deadlock. But if there is a deadlock, that will lead to circular wait, I can guarantee. For this, I can give the counter example in the later part of the videos. Just for time being, try to understood that if there is a circular wait, I cannot guarantee the deadlock. But if deadlock exists, there will be a circular wait, right? So these are the 4 kind of conditions that might true always when a deadlock happens, which means that deadlock is possible. Deadlock is possible when one of the following conditions, if you are able to observe. And one more point is there here I would like to discuss, that is a sufficient condition, right? Sufficient condition is concentrating on deadlock never possible. Deadlock never possible, right? If I say that there are 30 resources are there minimum, that can definitely avoid the deadlock, we can call it as sufficient condition, right? Sufficient condition means the minimum resources that is sufficient for us to overcome in the deadlock problem, we can call it as sufficient condition. If this condition is satisfied, then definitely there won't be any kind of deadlock. That is what the general meaning of sufficient condition, right? Yes. So these characteristics I can also call it as behavior of deadlock, or another terminology I can call it as symptoms of deadlock, guys, right? It's a just simple concept. If you are unable to understand it, just go through once again the video so that you can get the clear idea, right? Just follow my videos continuously. You can able to clearly understood, and you can able to solve any kind of gate questions also. Hope you understood this video clearly.